Number 16 on page 502. Solution is that to graph the function f of x equals square root of x. Okay. Now, similar to what we learned before, when we're graphing parabola, absolute value which is v shape, I would recommend you to memorize the shape. Okay. If you memorize the shape, you know how it's look like. All you need to find the remainings are a couple of points, so that it will help you draw the curve at the right position, okay, or at the right proportion. So, when you see square root like this, your graph will look like this, okay. It will have this shape. It look like half of a parabola, okay. So remember that when you have a function f of x equal to square root of x, your graph will look like this, okay? So, very similar to half a parabola, okay? So remember the shape when you see positive radical x. All right, to help you locate the point, I would say a couple of points, okay? Let's start with, now because you know that with this shape, the x cannot equal to negative value, right? The smallest x can be is 0, okay? So I will start with the smallest value, 0. So do not substitute negative value because it does not make sense, okay? So 0, what is f of x? So when x equals 0, f of 0 is square root of 0, which is 0, right? Because the radicand, the only two identical factors that their product, or when you multiply the two identical factor, will equal to 0 when you have 0 times 0, right? So this equal to 0. How about 1? F of 1. So square root of 1 is equal to what? Again, the radicand 1 is equal what time what? And these twos are identical factors. You got to think of what are the two identical factors that when you take the product, or when you multiply the two identical factor, would you this radicand 1, the only two factors, so 1 times 1, right? So you know that square root of 1 is equal to one of these, which is 1. So when x of 1, f of 1 is 1. Okay. Now, you can start with 2. It's up to you. But think about this. 2 is a prime. And remember, is a prime. The only two factors of a prime is 1 and itself. So there's no way you can find identical factors, okay? So I would not recommend to pick x equal 2, okay? Pick some value that's not prime. How about 3? No. 3 is also prime, so I would not pick it. How about 4? 4 is not prime. Now, think about this. Not only that, when you find f of 4, right, meaning square root of 4, the radicand 4 is perfect because you can find the two identical factors, right? That the 4, what are those factors that are identical? 2 times 2, right, equal to 4. So 4 is perfect for this function, square root. So square root of 4 is equal to 2, okay? So 2. Now I would say probably 3 points is good enough. If you want, you can find more points because this is square root, okay? Maybe the next best one is 9, okay? 5 is a prime, so don't use it. 6. With 6, there's no way you can find identical factors, okay? So 7 in primes is not good. How about 8? 8 is good, but 8, there's no way you can factor out 8 that will use two identical factors, okay? So 9 is perfect. So if you want one more point, use x equals 9, because 9 you can find the two identical factor, which is 3 times 3. Okay, but I'll stop with 3 points here. Now I know the shape of a positive radical is going to be like this, increasing from left to right. Okay, slowly. It's like half of the parabola. So let's grab it. X, y. When x equals 0, f of x equals 0. So this point right here, 0, 0. Okay. When x equals 1, f of 1 is 1. So somewhere here. How about 4? 1, 2. 1, 2, 3, 4. So when x equals 4, what is f of 4, which is 2, right? So 2 here. Okay. So this is 4, 2. This is 1, 1. Now, since you know the shape, right? It's going to be half a parabola, right? So to connect them, okay, then you have the graph of f of x equals square root of x. Okay. Now you see, going from left to right is rising, is increasing slowly. Okay, but it's increasing up and up. Okay, slowly, but it's going up. Okay. All right. Let's graph g of x equal to square root of x plus 2. G of x equal to x plus 2. Again, since this is a positive square root, so you know it's going to have the shape look like this. Okay, half of the parabola. That's all you know. I would find a couple points first. G of x. Let's start with 0. 0 plus 2 is a prime, so I wouldn't recommend that because I don't want square root of a prime, okay? Because 0 for x, 0 plus 2, which is 2, right? So radical 2, square root 2, and 2 is prime, so it's not very easy for us to find the square root of a prime. So I would recommend you to start with 2. The reason is that g of 2, when you substitute 2 for x, you get 2 plus 2, which is what? Square root of 4. And we found earlier, right? Two identical factors. 4 is 2 times 2. And product of 2 times 2 is 4. So that means square root of 4 is 2. So that means at x equal 2, g of x equal to 2, which is here. Okay? Now let's see what else that can help it. I would think 9. So how do you find square root of 9? That means x got to be 7, right? So when x is 7, 7 plus 2, which is 7 plus 2 is 9. Again, 9 is equal to identical product, which is 3 times 3. So that means square root of 9 is 3. Okay? So at x equals to 7, g of 7 is 3. So I have 2 points so far. You can find one more point. Did you remember that square root of 1, so square root of 4, square root of 9, square root of 16? These are easy, okay, when you find the square root, because the radicand 1, 4, 9, 16, with these radicands, you can find the two identical factors. With prime it's hard, with other numbers it's hard. Now so far I use 4 and 9, okay? Is there any way you can use 1? Radical 1? Think about the one right here, right? X plus 2. The only way this x plus 2 is equal to 1 if you have x equal to negative 1, right? Think about negative 1 plus 2 is what? 1. So actually, for this example, g of x equal to square root of x plus 2, I can use a negative x, okay? So let's try. At x equal to negative 1, square root of negative 1 plus 2. Simplify, you have negative 1 plus 2 is 1. And you know, right, square root 1, the two identical products, the two identical factors are 1 and 1. 1 times 1 is 1. So you know that square root of 1 is equal to 1. So at negative 1, I get g, at g of negative 1 is 1. Alright, let's start graphing. All I know so far that the shape of a positive square root is half of the parabola, something like this, okay? That's all I know. Let's start with the first point, negative 1, 1, negative 1, 1. Okay? You know, yeah, that's good. So this point is negative 1, 1. Second point is 2, 2, right? So 1, 2, 2 here. This is x, this is y. So this point 2, 2 is here. Okay. The third point is 7, 3. So 1, 2, 3, 4. Let's see. 1, 2, 3, 4, 5, 6, 7. Okay. So 1, 2, 3, 4, 5, 6, 7. And 7, you get 3, right? 1, 2, 3. So up here, 3. Somewhere here, okay? So 7, 3. Do you see that all the points is going up, right? This way. We just don't know what point it will end up here, okay? This was a little bit tricky. But you know, in general, it's going to be something like this, going from here to here, going from here to here, okay? And we know that it will end up something like this, okay? We just don't know what this value is. But you know that this value happens when you have y is 0, right? You just don't know what is x is, okay? That will make y equal 0, right? It's on the x-axis, right? On this axis, that means y equals 0, right? The only thing you don't know is what x is at. You can find that x by solving. Just ask the question. I know this is 0, right? The y is 0. So I know plus 2 here. So what x is that? That add with 2 would make square root 0, which is equal to 0, okay? So what x is that? It got to be negative 2, right? Because negative 2 plus 2 is 0, and square root of 0 is 0, okay? So you know, got to be at x equal to negative 2. Okay, so this is how you graph the function g of x equal to square root of x plus 2, half of the parabola. And going from left to right is slowly increasing, going up.